key space in deep tech, that is quantum computing. We're going to have a panel discussion coming up, but first, to open this portion of the program, we have general partner from Constructor Capital, Marie Lepske. Marie. Please welcome Marie Lepske, everybody.
Ladies and gentlemen, many thanks for coming here to our Constructor Start Demo Day. These three men, Clark, Deverett, and Martinez, won the Nobel Prize in Physics last October. They discovered that quantum mechanics works at the scale of everyday electronics. They proved it in 1985. Nobody outside physics cared for 40 years. But look at this timeline. 5 Nobel Prizes tied to quantum technology, and 3 of them during last 4 years. The pace is accelerating. The world's most prestigious scientific body is telling us louder and louder, this technology is real. So why now? Because what started in a Berkeley lab is becoming a $100 billion industry. Today, I will show you one thing, the momentum. Not promises, actual signals that this market has crossed its inflection point. First of all, let's look at the knowledge exposition. On the left, scientific publications and patents filings. Both show roughly 11 times growth over 2 decades. Publications went from a few thousands per year till 28,000 roughly. Patents filings increased to 300% just between 2016 and 2021. Every paper is a potential startup. Every patent is a defensive position in a global race. And it is a race. China now holds 60% of all quantum technology patents globally. But the chart at the right shows us a more nuanced story, volume versus quality. China as a country leads in volume since 2022, but US leads quality. Europe as a region leads in a volume, and it's the second in quality, with Germany at about 6% as the largest single European contributor. And what is the number one institution in the high-impact quantum technology research? TU Delft in the Netherlands. The quantity race is real, and the quality is where breakthrough is coming from. Now about the money. The left chart shows annual venture capital flowing into quantum startups. Look at 2023, the dip. The industry calls it the quantum winter. Funding dropped 40%. But look at what happened next. $3.77 billion just in 9 months of 2025. More than a full year in quantum history. The quantum winter wasn't a death. It was a stress test, and the industry passed. The majority of funding goes to quantum computing hardware, more than 80%, but software is also fast-growing number, $600 million approximately during 2024 alone. On the right, government multi-year commitment, $55.7 billion cumulative worldwide. Look at the top 4 spenders. China claims $15 billion, but this number is disputed. Europe collectively holds $10 billion. Germany is $4 billion out of these $10 billion. The US is nearly $8 billion. And it is all up, $70 billion in total capital deployed. That money builds labs, trains people, creates infrastructure. They doesn't disappear. Money alone doesn't build the industry. You need a full ecosystem, education, workforce, infrastructure, and manufacturers. So let's look at what happened in 5 years across the ecosystem. Education, 15 dedicated quantum degrees programs became 45, 3 times growth. And Germany leads the world in quantum master's programs, followed by UK and US. These 3 countries in total holds 45% of all quantum master degrees programs. Workforce. Skills demand in the US labor market has almost tripled since 2018. Companies are competing for quantum talents now the same way they competed for AI 5 years ago. Infrastructure, quantum networking testbeds, the backbone for a future quantum internet, grew 6 times across Europe and US. And manufacturers, the companies actually building and selling quantum processors went from a fewer than 10 to over 2024 with more than 160 GPUs running across 70 countries. Look, all directions go up. But what is the market value? Combined valuation of leading quantum companies around 2020, before SPAC era, we had $9 billion of combined valuation, and today 60 billion for the early 2026, 7 times growth. On the right, the companies behind that number. IonQ peaked at $30 billion last year. Quantinuum is valued at $10 billion and just filed the IPO that could value it for $20 billion. 4 private unicorns, including our portfolio company called Atom Quantum Computing, Quera. 3 new SPAC were announced last year, Xanadu, Inflection, and Horizon Quantum Computing. And 1 IPO of Quantinuum just was filed, as I mentioned. 2 new SPACs during last several days, IQM and CQC. Notice the SPAC timeline. So 1 in 2022, 2 in 2021, 1 in 2022, 0 in 2023, 2024. It was a quantum winter, as I mentioned, and 3 in 2025. 2 new ones, 2026, and 1 IPO just filed. The market was frozen and then came back stronger. Valuations is one thing, revenue is another. 2025 was the first billion-dollar revenue for quantum computing. McKinsey confirmed 700 million in 2024, and the industry crossed 1 billion last year. That's roughly a 20 times increase from where we were in 2020, sorry. What counts as that revenue? It's a mix. It's hardware sales, actual quantum processors shipped to the customers, cloud access, quantum as a services, where companies rent time to remote QPUs, software licensing, consulting, and integration and control electronics, the classical equipment that makes quantum systems run. This is the scope of quantum computing revenue. The broader combined quantum technology market revenue, which includes sensing, quantum K distribution, post-quantum cryptography, and enabling infrastructure like lasers and cryogenics, is already at 2.7 billion in 2025. I want to be honest, most of this revenue is still exploration revenue. Companies paying to learn, to pilot, to understand the technology. True quantum advantage revenue is still ahead, but the commercial pipeline is real and growing at over 40% per year. So here's my thesis, not a forecast, in 5 facts. The science has proven 5 Nobel Prizes accelerating last year. Capital is surging, 70 billion deployed. The talent pipeline is real. 15 programs became 45 during 5 years. QPU manufacturers tripled. Revenue crossed 1 billion in 2025, the first billion-dollar revenue year. And valuations show conviction. 9 billion became 60 billion for the last 5 years. Every metric points in one direction, and it is up. Now, I don't want to leave you without addressing the hard question. When does quantum actually become useful? And how does it compare to what we already have? Today, we have about 1,000 physical qubit systems. We need roughly 1 million for fault-tolerant computing. That's approximately 1,000 times scale up, expected around 2013 to 2035. And applications, chemistry, material science, cryptography, optimization, and quantum machine learning is emerging as a serious option. The common thread, big compute on a small data, not databases, not traditional machine learning problems where the computational space is exponentially large. Current total revenue from real applications, current total revenue from real applications, not computers, is less than 50 million USD. And yes, there are alternatives improving fast. Classical GPUs keep scaling. Optical computing, neuromorphic chips, and probabilistic computing, which is the topic of the next speaker, Nobel Prize winner and our new president of Constructor University, Dr. Konstantin Novoselov. So here is the investment view. We see companies today valued up to $30 billion, and 100 billion plus market is credible. But a trillion or 10 trillion, that's unclear. Fault-tolerant quantum computing is far away, and the competition from alternative technologies as probabilistic computing is real. The question is, who builds the infrastructure, funds the companies, and trains workforce to get there? That's the opportunity in front of us. Thank you.
Okay, thank you so much, Marie.